Here we are. We're going to take a look at this next module, jumping into Module 2, 2.1 Pet Sitters. So remember, this task is a develop understanding task, so we're just starting to get some ideas going here, okay? So there's quite a bit of reading, so follow along with me so that you know what it says. Make sure you guys are paying attention. There's going to be some times when you need to try problems on your own or in your groups. That's what I expect you to do. So, the Martinez twins, Carlos and Clarita, are trying to find a way to make money during summer vacation when they overhear their aunt complaining about how difficult it is to find someone to care for her pets while she will be away on a trip. Carlos and Clarita know they have found the perfect solution. Not only do they have a large unused storage shed on their property where they can house animals, they also have a spacious fenced backyard where the pets can play. So, they want to start a business essentially. So, Carlos and Clarita are making a list of some of the issues they need to consider as part of their business plan to take care for... Wow. Let's try this again. Carlos and Clarita are making a list of some of the issues they need to consider as part of their business plan to care for cats and dogs while their owners are on vacation. So, this first issue they came up with. And now, on your homework, there's going to be a list of more of these, okay? Some of the other ones that they came up with. And you'll deal with that on the homework. But for right now, we're just going to start with this one. So, startup costs. Carlos and Clarita plan to invest much of the $1,280 they earned from their last business venture to purchase cat pens and dog runs. It will cost $32 for each cat pen and $80 for each dog run. So, important numbers to note. Okay, to buy the cat pens, $32. To buy the dog runs, basically the dog pens, it's $80. Okay, and they only have $1,280 to start off. Okay, couple pieces, important piece of information there for us. So let's move on. Of course, Carlos and Clarita want to make as much money as possible from their business, so they are trying to determine how many of each type of pet they should plan to accommodate. They plan to charge $8 per day for boarding each cat and $20 per day for each dog. After surveying the community regarding the pet boarding needs, Carlos and Clarita are confident that they can keep all of their boarding spaces filled for the summer. So the question is, how many of each type of pet should they prepare for? Their dad has suggested the same number of each, perhaps 12 dogs and 12 cats, or in the other order, 12 cats and 12 dogs. Carlos thinks they should plan for more dogs since they can charge more. Clarita thinks they should plan for more cats since they take less space and time, and therefore they can board more. What do you think? What recommendations would you give to Carlos and Clarita, and what argument would you use to convince them that your recommendation is reasonable? Okay? So, what we're looking for this first little bit is how much they charge for a cat and for a dog. So, thinking back to this, the startup costs, and this, the question is, how many dogs and cats would you suggest that they have in their business? Okay, so I'm going to have the substitute pause the video, and I want you guys to take a look and try to figure this out. Try it on your own first. Try to come up with one or two different variations, the one that you think would be the best. Okay? Because you want to tell Carlos and Clarita the best possible combination of dogs and cats. So, look for the best. Talk it over with your group once you've got your number of dogs and cats, and check to see how much they would earn, see how much it would cost to house that many dogs and cats, and come up with that best number. Then within your groups, talk it over, kind of see what you guys came up with. Then we'll talk a little bit more about it. So about 5 minutes. Alright, well hopefully you guys had some good discussion and came up with different numbers, trying to figure out which would be the best. So, if we're thinking about this, there's two things you basically had to do here. So the first thing was, for however many cats, you said you'd have to times it by 32. Okay? So let's take, for example, I think what the dad said, 12 cats and 12 dogs. Let's try that. So if I go, actually, let's try it here first. So $8 per cat, so I'd go 12 times 8, right? And then I add to that the 12 dogs times 20. So then I figure out what that is, and using my calculator or my brain, we get $336. Okay, not bad. You may have got something more, you may have got something less. However, there's one issue, right? We have this constraint. Okay, and a constraint is something that makes it so not necessarily all our answers will work, right? Because that's great if I can fit 12 cats and 12 dogs, but do we have that much money to get their materials? So I have to double check that too. So I'd go 32 times 8, not times 8, times 12 for my cats, plus 80 times 12 for my dogs. So you should have done a similar thing to double check your information. It's all great to come up with a number you want to do, but when you have a constraint, something that holds you back, we can check that. So I get $1,344, right? So according to this, 1,280 is what, the maximum amount I could have had, so I'm over. So if we take a look on the back side, as Carlos is considering the amount of money available for purchasing cat pens and dog runs, he realizes that his father's suggestion of boarding the same number of each, perhaps 12 cats and 12 dogs, is too big. Why? Well, we saw it cost too much, right? We can't afford that. So, wants us to find at least 5 more combinations of cats and dogs that would be too big based on this startup constraint. Plot each of these combinations as points on a coordinate grid using the same color for each point. Okay, so we're looking at the ones that cost too much. So we've got cats, right, and dogs. So we'll kind of make a T-chart here, right? So we already tried 12 cats and 12 dogs, and that was too much, right? So what else would be too much? Well, pretty much anything above 12 cats and 12 dogs. So, basically anything more than 12 cats and 12 dogs, right? We could go 13 cats and 14 dogs. And what would that give us? Well, using your calculator, we do 14 dogs, 13 cats, okay? 13 cats, 14 dogs, that was 1,536. That's bigger than 1,280, right? This one was what, 1,344? So we need some more. So what else could we do? Well, we could do 20 cats and 20 dogs, right? That would definitely be too big. So if we put that in, that's 2,240, way too big. Okay, but what are some other ones that maybe we could do that are just not quite so large, closer to it? Okay, so we could take a look and see 12 and 12 was too big. What if we had 10 cats and 12 dogs? Okay, that's actually 1,280. Okay, 10 cats and 12 dogs. So that's something we'll need to hold on to later on. Okay, so that one didn't work. What about 11 cats and 12 dogs? Yeah, 11 cats, 12 dogs is 1,312. Too much. Okay, what about if we cut down our dogs? Let's say we only did 10 dogs. How many cats would we have to do? Okay, let's say 15 cats. How about? Nope. 15 and 10 actually gave us 1,280 again. So we'd have to go 16 cats, right? Alright, so 16 cats, 10 dogs gives us 1,312. Alright, so we can see that there's a lot of different points we can have here. So now it wants them to graph us. So let's take a look at that coordinate plane. So we called our cats this, dogs we'll call this. Okay, so then we plot those points. So we had 12, 12, 13, 14. So So there's 10 right there. This is kind of a big graph, but looks small, doesn't it? So there's 10 on the vertical side. So ours was 12 and 12. So 12 and 12 would be right there. Okay, so there's that point right there. Maybe I should get a smaller graph, huh? Okay, give me a second. I'm going to get a smaller graph. Just to make it easier for us. Alright, this graph looks much better. Okay, so we'll call this cats, this side dogs, and then our first one was 12 and 12. So over 12, up 12, there's our first point. Then we also had 13, 14, 20, 20. So 13, 14, 20 and 20, 11 and 12, and 16 and 10. 11 and 12, 16 and 10. Okay, so there's all those points. So green, remember, is too big for our constraint. Okay? Alright, so now the next question, number 2, is what would not be too big? Okay, in other words, what would be too small for our constraint? So the number of cats and dogs. So we could do something like 3 cats and 2 dogs. Okay, let's see how much that would give us. So you put it in to your calculator again, 32. So you know this is what we're doing each time, 32 times the number of cats plus 80 times the number of dogs to get to that number to see if it's too big or too small. So we put it in, and that's 256. Definitely too small, right? So we could keep going. We could do like 5 cats, 5 dogs, and here's a bunch of others. So looking at all of these, I hurried and filled them out for us. Okay, we can see that they're all under that 1280, right? So we can go plot them. So 3, 2, 5, 5, 6, 7. So 3, 2, 5, 5, 6, 7. We've also got 8, 10, and 10, 2. 10 and 2, and 8 and 10. So these ones were too small. So hopefully you can kind of see we've got too big, we've got too small. Our next question is going to be, alright, what is just right? What is right on the 1280? So now we want to know what? We want to know the number of cats, right? 32 times number of cats plus 80 times the number of dogs equals 1280. Hopefully you've noticed that we can make an equation here because, you know, that's essentially what we've been doing. We also found out with a couple, right? We found those two just by chance. So what I want you guys to do now, take about 5 minutes. We've already got 2, 10 and 12, and 15 and 10. See if there's any others, numbers of cats and dogs, that you can get that would add up to 1280. Okay? Alright, take about 5 minutes, see how many you can get. Alright, so looking at this, hopefully you guys came up with these, because these are the only possibilities, really. Anything other than this doesn't work, right? You can't have a negative number of cats or dogs, so that doesn't work. Hopefully you took a look at these and started like this. Said, well, how many total dogs could I get? Well, if I wanted to know how many total of these, basically I wouldn't have any cats, right? You could have put in 0, solved it for D, and got that. Same with this one. If you wanted to know how many cats could you get without any dogs. Now, of course, if you have 40 cats, you are a crazy cat lady, but it still works. So these are all the possibilities. Now, if you got any numbers other than this, then you either did it wrong or you're getting partial animals, which most owners that I know of don't care for a partial animal. Okay, so now let's plot all these points. So we start at, let's see, I don't think we're long enough quite to there to make it, are we? So 0, 16. So 0 cats, 16 dogs. Okay. Then 5 and 14. So up 5, or right 5, up 14. Okay. Then let's go 10 and 12. So 10 up to 12. Our next one, 15 and 10. Over 15 up to 10. Okay. 20 and 8, then 25 and 6. So 20 and 8, 25 and 6 would be somewhere here, and so on. Okay. Till we got it past there. Alright, so if you look at those, do you kind of see something here? Okay. And look at the green ones, look at the orange ones, look at the blue ones, right? The blue were just right. Okay, do they look kind of like they're a line altogether? Not really, they're all over the place. What about if you just pick out one color? Does it look like there's a line? So this is, of course, answering question number 4. What do we notice about these collections? Well, notice that all these green ones are kind of over in this section. The orange ones are over here. We could have probably picked some of these, and if you wanted to check some of these other points, you could. But where are the blue? Right in the middle. Okay? Basically making a line, right? If you look at it, you've got some slope going on here. The same slope. So, write an equation for the line that passes through the points representing combinations of cat pens and dog runs that cost exactly 1,280. What does the slope of this line represent? Well, we kind of already came up with one equation, right? We said it was 32 times the number of cats plus 80 times the number of dogs equals 1280. Okay, there's one equation. Okay, that's standard of form equation. Now, what about if we did it this way? Okay, think about slope. Well, our y-intercept would be 16, right? Slope-intercept form is y equals mx plus b. So our b would be 16. What would our slope be? Well, we go down 2, so that's negative 2. To the right, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. So, it would be negative 2/5 x plus 16 equals y. Or to put it in these other terms, dogs equal negative 2/5 cats plus 16. Okay, so what does the slope represent here? Well, you can think about it. Every time I take away 2 cats, I can give myself 5 dogs, right? Because in our table, the input was cats, the output was dogs. So as this changes by, I mixed it up, dogs over cats. Every time we lose 2 dogs, we gain 5 cats. So notice that we're counting by 5s. So every time we move by 5 on the cats, we move up on the dogs too. Okay? Now, here's something interesting to think about. Carlos and Clarita don't have to spend all of their money on cat pens and dog runs unless it will help them maximize their profit. So thinking back to this and looking at number 6, shade all of the points on your coordinate grid that satisfy the startup cost constraint. Well, look at that. Okay, where are the areas that are going to be too small? Basically, anywhere underneath that line, right, is going to be too small. So there's all these possibilities here that could work. Yes, I could only have 1 dog and 1 cat at a time. Would I make as much money? No, but I could do it. Whereas up here on the green, we can't. Okay, we don't have that much money, so we can't work on that. So shading it, we would shade in all these points. All these points are possibilities. They're all answers. They're all solutions. They all work within that. However, not within the equation, right? And like we talked about a couple times ago, not everything needs to be equal to something. Okay, sometimes it makes more sense that this is the maximum you can have, but there is a minimum. So if we think about this equation, 32c plus 80d equals 1280. So let's think about it like this, okay? Right, a mathematical rule. So in essence, an inequality whose solution set. Now, that's just a fancy term for all the possible answers. Because if we look at the graph, my answer could be 3 cats and 10 dogs. My answer could be 9 cats and 6 dogs. So because there's a bunch of possibilities, we think of it as a solution set, not just one answer, not x equals this, but a whole set of possibilities. Okay? So that satisfy the startup cost constraint. So think about, how would I make this work? And think about those inequalities that we have. We have greater than, which means this side is bigger. Less than means this side is bigger. Okay? Greater than or equal to, so this side is bigger or equal to, or less than or equal to. This side is bigger. So think about here, which side here has to be bigger? Well, this represents the money, right? So that should definitely be bigger. So it's definitely going to look like that. Now the next question is it all right for it to be equal to? In other words, can I spend the exact amount of money? Yeah, so it could be equal to it. Okay, and there we go. That inequality is a better idea. And that inequality takes into account two things. It takes into account the line here. It also takes into account all the answers here. Because our answer could be on the line, or it could be on the graph, meaning below the graph in that shaded area. Okay? So on your homework, you're going to have some more problems like this with different constraints. So I want you to treat it the same way, and to take a look at those and see if you can come up with what's required of you to answer those questions. Alrighty, you guys have a good day. We'll talk to you later. And if you're watching this and you're not in my class, so you're watching at home, that's great too. And probably a little bit different. So, bye.